So we're going to get started on a TPO peel and stick. Here you will find a perimeter securement, high pressure sensitive. So the pressure sensitive securement will get a primer, and what this does is it allows you to continue the membrane all in one piece up and over the parapet. So the average crew for a thermoplastic installation is 5 to 6 men. Typically, you get about 50 to 60 square in a day, which is about 5,000, 6,000 square feet of production. This is typically a good mechanically fastened systems. So they're very fast, very efficient systems. So best practices for roofing membranes is typically you would open up your sheets of membranes and let it relax. So you will notice here we have a modified 2-in-1 board for the demonstration here today. So this is going to be our hybrid system. What we're going to have here is we're going to have a fleece back membrane. That's going to be fastened with a liquid asphalt. So Steve and Kyle are commencing to rip out the plastic peel and stick. These peel and stick membranes are stick very well when cured to the insulation. They get very good wind uplift resistance. And then typically they can be rolled with a 100-pound roller or broomed into place, as you can see Steve doing at this point in time.
Can you show me the storage area?
So as you can see, the primer's cured, and the tech reps are starting to glue it to the parapet. That didn't take very long at all, as you can see. They're just kind of on the parapet, wrapping up and over, and then typically you would nail a few nails onto the parapet. Our insulation boards today, we're working with about an 8 fastener per board, which is pretty typical. Typically in mechanically fastened systems, you'll find 6 fasteners per board. So we have Rocco there starting to relax our fleece back membrane sheet. He's rolling it out. As you can see, the fleece back has a bare spot where we will commence our welding onto the other TPO. Membranes you'll see on the floor today are right now are TPO and PVC. Todd here is starting to apply adhesive on our fully adhered system. So this is going to be a fully adhered PVC. As you can see, Kyle here is dropping our protrusion. We've pre-wrapped this box with TPO membrane. So now we have, here we have liquid rubber being installed, and that will get squeegeed over the modified. So this is a redundant system. So anytime you want to provide redundancy in a single ply system, this would be the application for it. You have a liquid rubber right on the modified, all cold applied, no odors. As you could tell, it doesn't smell. Very efficient Um, and once that sticks, you get very, very high wind uplift values. So why fleece back technology? Well, number one, toughness and durability. Productivity is very fast because you have the wide sheets, a superior wind uplift resistance. You have no fastener options with this type of option in the fleece back area. Great for retrofits if you're doing a retrofit on a built-up roof system that you have dry. It's a dry substrate. You can retrofit very easily with the fleece back technology. Can provide additional thermal efficiency, excellent puncture resistance. It's a very quiet, adds a quietness to your roof systems, and very low odor. It's an excellent alternative to asphalt systems. It's got and you get the weatherability benefits to the PVC, KE, and TPO. So the fleece back products are typically available at 100, 150, 135, and 145 mil. So total sheet thickness is what I'm letting you know here. The rule of thumb typically is if you have a 60 gauge TPO membrane or PVC, you can add 55 mil of fleece, which will give you your total thickness value. So, so typically rolls come in about 10 foot wide by 100 foot. So if you're looking at comparing seams to a standard roll that's only 39 inches wide, you actually gain 73% less seams than a 39-inch roll that you'd have in a typical sort of built-up roof system. So types of, so here we have Mark. He's starting to relax his membrane so he can get ready for his fully adhered PVC. Fully adhered systems are getting the durability points these days. I guess because some people feel that a loose membrane on a roof deck is not very efficient. However, nothing wrong with mechanically fastening every 12 inches on the seams. Ways to enhance your mechanically fastened systems: you can reduce your sheet size so you don't get the fluttering. You can also have a fully peel and stick continuous vapor barrier will reduce your wind uplift by 50%. So it actually creates a suction on your roof, but just by doing a simple, very good peel and stick vapor barrier under your mechanically fastened roof system. So we'll take you back to the fleece back technology. So different types of adhesive options for fleece back. You have hot oxidized asphalt, right? So this could be laid in hot asphalt. You have SBS options, so styrene, ethylene, butadiene type adhesive can be put down. Cold applied bitumen adhesives, high performance modified, or hot rubberized asphalt. So right now Rocco is getting the urethane, 2-part urethane adhesive gun ready to put down in a bead style fashion. So this is another option that we have for our fully adhered fleece backs. So the one and 2-part insulation adhesive can add R value, eliminates VOC concerns, also reduces noise and odor. As you can see, Rocco there is applying it every about 12 to 6 inches. The tighter it goes, the better the adhesive will be. The better wind uplift you'll get, and the better close to a fully adhered system. So now once that raises to a certain consistency, that membrane will be ready to be rolled into the urethane. As you can see, it is sort of flattening out and expanding and expanding into shape. Try to avoid it developing a skin, because once it's developed the skin, then it could harm its adhesion qualities. So there's Steve there, he's putting in a drain, he's putting his hopper in, and we have a typical term patch going over. That term patch is about 3 feet by 3 feet, and sort of shingling away from the drain. Typically we would have a tapered sump here, so you'd typically have 2% slope tapered, and we'd also have a mastic going underneath the membrane, the connection of the membrane to the hopper. So I think Rocco's getting ready to roll his fleece back into the 2-part polyurethane. So once that fleece back is rolled into its adhesive, typically you'd be pushing that in with a broom, or you can have someone roll behind with a 100-pound roller. Very fast, very efficient. So this type of urethane, 2-part urethane adhesives get very high wind uplift resistance. And there's Todd there. He's applying the adhesive to the PVC for fully bonded. They've got 1/2 fully adhered. So a little about thermo-plastic technology. So as you can see, Kyle there, he's welding the membrane. So thermoplastic can be softened by heat and hardened by cooling through a temperature range, a characteristic of plastic, and that is softened state can be shaped by flow into articles by mold or extrusion. So that ASTM standard D883 is your typical standard. So we have 3 types of single-ply membranes in the market. We have TPO, PVC, and KEE. So the PVC is polyvinyl chloride. So its ASTM standard is D4434. And we have TPO, which is thermoplastic polyolefin, and its ASTM standard is D4434. And then we have KEE, which is not on the floor today, but it's ketone ethylene ester. So PVC being one of the oldest membranes in the market, so typically we would, as Steve's pointing out to me, is typically we would be installing a mastic, a waterproof cutoff mastic under the membrane prior to putting the drain clamp on. And then once that drain clamp is on, you're watertight from the inside of that clamp to the inside of that hopper. So Steve right now is starting to screw down his clamp, and then he'll proceed to put his screen on. As you can see, Kyle is fully welding his flashing right to the TPO membrane, and he's almost finished that roof curb. All he's got left is corners. We got Mark and Todd here. They've pretty well completed their fully adhered base. So we've pretty well got most of the field in place, with exception to our Rhino Bond system here. So PVC happens to be one of the oldest single-ply membranes in the market. It came out in around the 1960s, sort of post-war technology. And TPO is a diverse family of rubber. TPO is typically based on polyethylene and ethylene propylene rubber polymizer, together using state-of-the-art polymer manufacturing technology. This technology enables the product of TPO to remain flexible in low temperatures without the use of liquid plasticizers. And then our KE, our ketone ethylene ester, kind of began in 1977. It was the DuPont developed a higher molecular weight solid plasticizer and labeled it Alveoli Key High Performance. This increased the performance and stability of the PVC beyond what a liquid plasticizer can do, generally resist to chemicals, pollutants, abrasions, acid rain, oils, animal fats, jet fuels, and intense solar lighting. So we got Devin providing perimeter enhancement screws on the perimeter. So he's preparing the a separate. This is separate flashing. So this is what you'll see behind what a separate flashing detail will look like. Same with Todd here. Todd's screwing down membrane fastening plates. Like the ones I've handed out in the crowd. So along with the testing of time, weatherization, these membranes, through their ASTM standard criteria, undergo a long-term heat age test. One of the methods is Exxon Arc, a long-term heat aging test, the long period of time, up to 32 weeks at 240 degrees Celsius. Sorry, Fahrenheit and 116 degrees Celsius. So a big change in the thermoplastics today is 60 gauge membrane for TPO and PVC have typically been the norm. I think it's helped the durability of the membrane enormously, and basically helped manufacturers give 20-year plus warranties for these types of systems. A lot of these systems are available in between 20 and 30-year warranties. Depends on the specification of the manufacturer. As you see, Mark now commences induction welding system. So he's gauged his gun, and he's placing his magnet. So this is an all-in-one system. Use the same fastener and plate to secure the membrane to the insulation without penetrating the roof membrane. So how it works, induction weldable plates are placed in a pattern as seen. So typically if you have an insulation pattern of 6 to 8 patterns per board, a 4x8 board, basically at each insulation plate, that membrane is fastened to it. So the membrane is laid out, positioned, and the seams are hot air welded. The induction weld tool is positioned into place directly above the plate. The tool adjusts special coat. It has a reaction to the special coating on the plate, and bang, you got yourself a connection right at the insulation plate. So this results in a bond between the plate and the membrane. The weighted magnets are then planked over the plates to dispense the heat and ensure contact. Induction welding tools operate on standard 120 volt power source and typically draw 1300 watts of power. So what some of the benefits of induction welding? Reduces fasteners, plates. You could go with full sheet sizes. So if you're using a 12-foot sheet, you can continue that. You can use that 12-foot sheet throughout the whole project. You can also allows you to run the membrane up and over the parapet without having a separate flashing. You have symmetrical wind distribution, so when the wind hits it, you reduce the fluttering considerably on the membrane that you've attached because you have so many tight fastening points. So it's a very sleek and smooth system. Some people find it quicker than standard mechanically fastened. You can also enhance your perimeters with induction welding, which is a very good point. So you can mechanically fasten, like you see in the middle sheet here, 12-inch centers, and if you need a perimeter enhancement, so if you have to reduce your sheet sizes for FM perimeter enhancement, you can do that with the induction welding machine. So that's another option for you. So as you can see, Kyle is almost finished his protrusion there. And he's preparing his prefabricated corner. That's another great benefit to these single ply systems. A lot of prefabricated accessories are available. For example, you have inside, outside corners, save on time and save on errors of workmanship. We also have prefabricated pipe boots for protrusions, beams. Very, very handy tools. So now Devin over there is starting to starting to glue his separate flashing. So that everyone's relaxing their membrane. For the demonstration today, we sort of pre-cut our membrane, so basically it's rolled up a bit, but usually that would be all pre-cut off of a relaxed roll on the job site. So a little bit of history on thermoplastic technology. It was a great solution after the oil crisis back in the 70s. Today we have a great history of what to do and what not to do in the thermoplastic world. So it's got a great history, and the industry has learned from some of its mistakes and improved things tremendously through its ASTM standards that are out there. So as I was mentioning earlier, the history's gone through using 60 gauge single ply. The 45 gauge typically used only in large warehousing type establishments. Nowhere, like if you have doing institutional work or any kind of hospital work, we highly recommend going 60 gauge. All the membrane, most of the single ply thermoplastic membranes are constructed with a reinforcement scrim. So you have a back part and a facer. The important thing about it is that thickness over facer, which is why you need to be careful when you drop things on the membrane or if you're ballasting the membrane, because you don't want to damage that facer. That facer is what's giving you that 20-year weatherability. So one thing that I'd like to add is that 80% of the U.S. market currently is single ply membranes. So why is this such a growth in the American market for thermoplastics? Well, the technology promotes thinner layers, much lighter. They're much lighter, faster, and cost savings. It's a very tough membrane. So as we're using it as a cap sheet, it's a very, very durable cap sheet because it could be used as a single layer itself. It's factory made, so it's in a controlled environment. So you actually have a 4-layer system all made in a controlled, thin environment. It's simple and it's clean. So the typical welding temperatures that you're going to see here on the guns, they're running at about 450 to 600 degrees Celsius, depending on the weather that you're working in. So if you're working in the winter time, and these can be welded in up to minus 15, minus 20, you're looking getting your guns up to about 600, 650 degrees Celsius. And also, hopefully by the time this show ends, we're going to show you a cut test. So typically a welded seam, the welds have to be as strong as the membrane itself. So when you pull apart the weld, that membrane needs to be it needs to come apart. So Mark's applying his adhesive to his PVC flashing. Some manufacturers PVC does not have reinforcing scrim to the flashing, and then some manufacturers actually, I think I passed out, there's a for doing flashing applications, we have an unreinforced that's semi-cured that can be molded into any shape that you like, and so some manufacturers make a full roll that doesn't have a reinforcing scrim in it. So because we're inside, we're not outside, this is going to take a little bit more time to dry. So these are moisture cure adhesives. So our tech reps are going to be putting them on a little more wet than they usually go on. So typically the process would be is tacky. Once it's tacky, it can be adhered to the substrate. So as you can see, the typical bonding adhesives needs to be put on the substrate and the membrane itself. It's similar to gluing on a custom countertop onto a like a Formica or Arborite. So it's kind of taking the cabinet making world into the roofing world. So we have Kyle and Steven welding our term patch.
I brought one like that too. I'm like, I don't think I'm wearing it tomorrow. I don't know.
So another detail you can practice on your term patches. You can put a primer 3 inches away from the perimeter edge, so that it's fully adhered.
There's very few ladies.
And also, you know, good practice is to have at least two to 4 screws on your hopper, so that any wind uplift in a mechanically attached system, the clamping ring doesn't take the load, take all the load for that mechanically fastened system.
It's pretty much like,
Sean's giving a presentation for Sarnafeld.
yeah, I know, that's what it looks like.
It's so funny.
So it was earlier mentioned about safety. Today's roofing world, everyone has to be trained at working at heights. All roofers who have fall protection on construction must complete an approved working at heights training program. I believe the deadline extension for the Ministry of Labor is October 1st, 2017. So everyone has to be trained for working at heights at this time. And who's responsible are employers and also homeowners. Have to make sure that people are trained for working at heights. So some important factors about safety and safety equipment. You know, you have to inspect your equipment. The harness, the lanyards, controls require whenever you're working to an exposure of over 10 feet or 3 meters. Typically in a roof, you would have guardrails are required on all your parapets at anything higher than 8 feet off the perimeter. So manufacturing dates need to be checked on your safety equipment. All equipment has to be CSA ANSI compliance. You know, you have to have the capacity. It has to be tested. It has to be the correct size of equipment for the worker. Has to be in a. It cannot be in a fall. If a worker's ever been in a fall, he has to have all new equipment, new lanyard, etc. Nothing could be discolored or abrasions or breaks or cuts. So everything needs to be expected on a daily, if not bi-weekly basis. So we have the camera now on the tech reps that are installing our perimeter, separate perimeter flashing. As you can see, the flashing is overlapped the perimeter securement by about 5.5 to 6 inch standard. So the flashing's wrapped up and over the parapet and tacked to the outside, which is pretty common. And then typically, if you have a air barrier, it would typically tie in right at that location. Steve here is starting the robot, and he's going to start our seam
That robot.
welding.
The guy's starting the robot. I'm like, where?
These robot machines save a considerable amount of time, so that your average speed for welding TPO
Everybody's bored already.
in a good day, you're looking at about 16 feet a minute.
We got here halfway through.
So you can accomplish that much production.
I did that already.
Things to consider when you're welding TPO or PVCs or the thermoplastics
I actually got trained by a
is your
school
stop
guy
and
who's
starts.
standing right next to you guys, but he's disappeared.
So as you can see, Kyle is where the machine stopped. Typically, a good practice would be to put a mark right where the robot left off, so an applicator can go back and weld that portion. And then a typical role for a roofing crew and some of the tech representatives is they go and probe all the seams, which you will see at the end of this presentation. Also, where there's a T crossover, typically with for the TPOs, you'll have to have a T-patch. Reason for that is there could be a slight pinhole, so we want to make sure that no water can get in at at any weak location. So when there's a T, where a cross of a membrane, you'll get a you may encounter a slight pinhole, which is why Kyle here is going to weld a T-patch. So as you can see how clean this application is, no smells. The workers are very clean. So we got Rocco and Mark here on the thermoplastic side. Mark is, these guys are starting their corner detail. Very signature detail in the thermoplastic application world. So a little bit about sustainability for thermoplastics. Today's ASHRAE 90.1, paragraph 55311, states a solar reflectance and thermal emittance roof in climate zone 1 to 3 shall have one of the following minimum 3-year solar reflectance of 0.55 or a 3-year thermal emittance of 0.77. So increase roof insulation levels or provide a white or light colored membrane. These membranes and this technology is ideal to satisfy that requirement in the ASHRAE 90 code. Also, the recycling of thermoplastics. Plastics are 100% recyclable. Sheets can be grounded into flakes or pellets and sent out for just like any kind of bottle technology, plastic bottle technology. The recycled content can be used for the bottom ply of the membrane. So this is so it's got some very good sustainability criteria to it. So Rocco now is completing the PVC welding. So PVC and KEE weld a little different than TPO. They have a little bit of a bleed out that you can see when you're welding it. You can heat the membrane a little more, so you actually see a little bit of the bleed out of the plastic, whereas TPO shouldn't have a bleed out. It's more of a finicky weld, It's a little more precise. Has to be applied at the right temperature and the right consistency. So it is a little bit more difficult on the TPO side to see where you may have missed the welding part of it. It's a little bit more simpler visually to see the PVC side. That's why in TPO projects everything should be thoroughly probed with a seam probe. So now we have the robot getting ready to weld the flashing. So as you can see, the robot's made very narrow, and it can handle that 5.5 to 6 foot width of the flashing very easily, and you can do miles of it very quickly, very efficiently. So it looks like we have our induction welded plates all welded. Typically, when you're inspecting an induction welded roof, the basic tool you need is a plunger. So you take your plunger and walk around, and that's how you make sure that everyone's got every plate fastened. And then once, if there's something that's not fastened, you just put a little X on the mark or a little circle around the plate, and any applicator can quickly set up over that plate and induction weld everything. Also like to draw your attention to our sponsors, companies that have sponsored all the products for this demonstration. On the board there's, I believe, Sindot Consulting has sponsored the wall protection. And we have Atlas is not on the board. Atlas Insulation Corp, who's supplied the insulation for this demo. Back to our insulation topic. There are all other alternatives other than polyiso for roofing applications. Oh, here we go. We got Steve showing. So, as you can see here, this weld is as strong as the membrane. So that's what it should look like after a weld is done with the gun. So when you rip it apart, the membrane needs to come apart, not the weld. So, from the FM wind uplift testing, the seams have to be as strong as the membrane itself. So back to our insulation topic, there are two other types of insulations common in the Canadian roofing market. You have EPS, which is expanded polystyrene. It comes in different, typically different types, different densities, and different various thicknesses. And you also have XPS, which is expanded polystyrene, and it also is a very high compress and durable insulation, very low water absorbent. I encourage you to also look into these other alternative insulations. They can offer a lot of advantages to your roof systems as well. So what you don't see here is if you're doing vapor barrier continuity, good practice is to have the vapor barrier fully seal your roof around the protrusions, around the roof decks. Sometimes you can have installers filling the flutes around the decks. Try to get as much air less air into the system as possible. This can reduce your wind uplift by 50%. So it actually creates a suction onto the roof system, eliminate a lot of the fluttering that you might see. So our PVC guys are pretty well finished. Their corner detail. Steven there is getting ready to set up his robot to weld the membrane right to the back of the corner. Kyle is starting to put his unreinforced flashing on his corner detail. So as you can see, that's TPO corner detail, and this is PVC. PVC doesn't need the unreinforced flashing, whereas the TPO does, just to secure any kind of pinhole that might be in that system, in that weld. I think, what do you got, what time you got there, Tom?
How's the train right?
10-2. So, you guys almost done?
A little bit delayed.
Yeah? Okay.
Over here.
So our PVC demonstration is done. We're just going to finish up our thermoplastic. And
11:30.
I believe we have we have our pipe boot installed. As you can see, we have a pipe clamp.
I don't know where.
Maybe our tech reps could
How's
start to probe the
how's
seams
drive?
and show
Okay,
what
up until
what it looks like when we're
tomorrow, where
probing.
it gets just congested.
Yeah.
Rainy.
Time we'll go there.
So this is what these guys do day in and day out. They typically go around. We like the, we ask the roofers to probe prior to when we show up. But basically, if that seam goes anywhere in the membrane within a quarter to half inch, that membrane needs to be repaired.
What was Rob doing on his phone?
As you can see, the welds have been very well executed.
Multiple tasking.
Very little, very little voids found at this point in time. Kyle's finishing up his corner. And we're pretty well done this presentation, everyone.